Good morning and welcome to geometry. This will be your first lesson out of many that we're going to have. So uh, please feel free to take notes. You can take notes on the outline that was provided to you in class. You can take notes in a notebook. That is your decision on what you want to do with that. All right, let's go ahead and get started. This is all the basic vocabulary that you're going to need to get through geometry. So the first word, space. This is the set of all points. So if you want to visualize this, it's like looking into outer space and all of the stars are all the points that are included in the space. The points are a location in space with no size, represented by a small dot and a letter. So usually you'll see them on a picture. We'll have a dot and then they'll put a capital letter next to it, and that's point A. All right, a line. This is a series of points that extends in two opposite directions without end. They go on forever. So when you see them on a picture, they're going to have arrows on both ends. If you remember from algebra last year, when you graphed lines, they told you to put arrows on the ends of them because they kept going forever. When we name a line, you're going to name it by 2 points on the line. So let's say this line up here had a point A and a point B. Then we name it line AB and we put a little line above it to show us that it is a line and not something else. All right, collinear points. Co being together. Linear means line, so these are points that lie on the same line. So you'll have, 3 points, and if you drew a line through them, they would all be on the same line. All right, our first example of the year. Are points E, F, and C collinear? So if we look at E and F and C, are they collinear? And the answer would have to be yes, because they're all on the same line. All right, and then we look at point E, point F, and point D this time. Are they collinear? Answer's no, because D is not on the same line as E and F is not on the same line as E and D. And then actually if we drew a line through F and D, E would not be on that line either, so they are not collinear. All right, another word, a plane. This is not a plane that flies in the air. This is a flat surface that has no thickness. So if you think of a sheet of paper, you think of the surface of a wall that you put paint on. If you picture the surface of the floor, those are all flat surfaces. We're just talking about the surface. We're not talking about how thick it is. So that's a plane. All right, coplanar, same deal. Co is together, planar is plane. So these are points and lines that are on the same plane. When you see this in the book or in other diagrams, they're going to draw a plane kind of like that, like a rhombus. And then you'll have, some points on it and maybe a line on it, who knows. Okay, but those would all be coplanar because they're all on the same plane. All right, next example. It says each surface of a cube represents part of a plane. We want to name the plane represented by the front of the cube. So if we were to trace this, this is the front of the cube. I use a little imagination here. So to name it, you just name it by the 4 endpoints all the way around, and you name them in order. So if I start with A, then I could go to B, and then to F, and then to E. So this is plane A, B, F, E. You could start at B and go the other direction. You could go B, A, E, F. You could start at F and go F, E, A, B. It doesn't matter where you start. You just have to follow the letters around the shape in order. Okay, so planes can have several different names. All right, another word that you need to know is postulates and axioms. We will use postulates. If you take any college math classes, they'll use axioms, but we'll call them postulates. They are accepted statements of facts. So think rules. They are the rules of geometry. And we use these in proofs to help us get our ideas together and help us get to the end of the proof. All right, so postulate number 1, and you see this number up here? That number is specific to our book only. If you look in any other geometry book, it could have a different number. So do not memorize them by numbers. You need to memorize the information that's inside of them. Okay? So first postulate, it says through any 2 points, there is exactly one line. So think about it. If I give you any 2 points anywhere in the world, can you draw more than one straight line through it? If it curves, it's no longer a line. So it has to be a straight line. And that it's only possible to draw one line through 2 points. All right, postulate number 2. If 2 lines intersect, then they intersect in exactly 1 point. So if you draw 2 straight lines that are not the same line, then they can only intersect in 1 point. Postulate number 3. If 2 planes intersect, then they intersect in exactly 1 line. This one's a little harder to see. So you picture you've got 2 sheets of paper. So there's one. I'll make the other one a different color. Let's say the other one goes this way. All right, and it's back here. Okay, then they intersect in exactly 1 line. So right here, hang on. This is hard to draw. Here's one plane. And let's draw the other plane going this way. Alright, then where they intersect, which would be right here, would be 1 line. The easiest way to think about this is to look at how walls intersect. If you look at the corner of a room where the 2 walls intersect, the seam of the drywall is 1 line all the way up. Or if you picture like on the sides of a box, that is 1 line that goes down the side of the box. So that the planes of the box can only intersect in 1 line. Alright, so if we look at our cube again, what is the intersection of plane HGFE and plane BCGF? So HGFE is right here, HGFE, and BCGF is on the side, BCGF. So their intersection is right here, and that would be line GF. Or FG, it depends on how you look at it, but they're both the same thing. Okay, you can reverse the letters and it still gives us the same line. Alright, postulate number 4. Through any 3 non-collinear points, there is exactly 1 plane. And non-collinear is the key, because if they're collinear, then you have a line and there's infinitely many planes that go through that. So, I give you 3 points. This just happens to be in the plane of the computer screen. Those 3 points are on 1 plane, but I can't put more than 1 plane through them. It's like if I gave you a sheet of paper and asked you to draw 3 points, but all 3 of them can't be on the paper all at the same time. Can't happen. Alright, example 4, it says to shade the plane that contains A, B, and C. So here's A, and here's B, and here's C. The plane would be the bottom of the box, A, B, C, D. All right, example 4. Shade the plane that contains E, H, and C. Here's E, here's H, here's C. And if you're not sure about this, pause it for a moment and look at the shape and see if you can see the plane. Okay? I'll start drawing it in. You see it yet? It's a plane. It just cuts the box on the diagonal. So it's actually plane EHCB. All right, a line segment. This is part of a line. So picture, this is my segment. There's a line that goes on forever from both ends of it. It contains 2 endpoints. So here's one endpoint. Here's the other endpoint. And all the points between them. So picture millions and millions of points between these two because there's infinitely many points. To name a segment, let's say those are my endpoints. The name of a segment, you name the 2 endpoints and you put a segment over it. And that shows us that it's a segment and not a line. All right, array. This is a part of a line consisting of one endpoint and all of the points of the line on one side of the endpoint. So let's say this is my endpoint. Then the array would go everything to the right. So it would have an arrow on this side. And then somewhere in there would be another point that we could use. So to name the array, you start with the endpoint. You name another point in the direction that you want to go. And you put a little arrow above it. Okay, so picture this. What if our ray went the other direction? What if it started at B and went that direction? Then this would be ray BA. Okay? Rays are direction specific, so you cannot just reverse the letters and get the same ray. It actually gives you a different ray. All right, opposite rays are 2 collinear rays. So remember what collinear is. That have the same endpoint. So here's a point in the middle. We'll call it point C. And there's a point over here. We'll call it point E. And right here, call that point A, and it's a line, so it goes both directions. Then ray CA and ray CE are collinear rays, so they are opposite rays. And 2 opposite rays always form a line because they're collinear, so they just basically make the 2 pieces of the line. All right, so in this picture, we're going to name all the segments and all the rays. So let's start in with the segments. They should be pretty easy. We've got LP, we've got PQ, and we've got LQ. Because if you switch this around backwards and you say PL, that's still the same segment. If you say QP, still the same segment. If you say QL, it's still the same segment. Okay, but the rays are different. So let's say we have ray LQ. Starts at L and goes through Q. We could have ray QL. Starts at Q, goes through L. We could have ray PQ. Starts at P, goes that way. Ray QP is actually the same as QL, so we don't have to list that. We could have ray PL, start at P, go through L. But then if we said LP, start at L and go through P, that's actually the same as LQ. Okay, did I miss any? Double check. All right, some more words. This one should be very familiar from Algebra 1. Parallel lines. These are coplanar lines that do not intersect. And if you remember your coordinate geometry from Algebra 1, you would know that parallel lines have the same slope. And that's kind of important. That's coming up next week. All right? So coplanar lines that do not intersect. This coplanar is a big deal because if they're non-coplanar, they're not parallel. Not necessarily. All right, skew lines. These are non-coplanar. See why parallel lines have to be coplanar? That means they are not parallel and they do not intersect. They have no chance of ever being related to each other at all. Parallel lines are related to each other because they both go the same direction, like train tracks. Okay? So in this picture, we're going to look at line DC. So let's highlight him. Okay. Why won't it highlight? Maybe not. There we go. Line DC. We want all the segments that are parallel to DC. So they have to be able to have a plane that goes through both of them. Like line AB. AB is parallel. Okay, so we'll put that in the list. Like line GH. That is parallel. Like line JI. That's also parallel. Okay, if we knew what these two red dots were, that would be another parallel segment. There's a parallel segment on the back from M to whatever is over here. We just don't know what it is. But those would also be parallel. Okay? Now, if we had segments that are skew to DC, I'll put them in orange, then that means they cannot be parallel. So it can't be one that we've already named. And they cannot intersect. So like DG doesn't work. But MJ does. Because MJ has no chance of ever intersecting DC because DC is going to go out here somewhere. And it's not parallel. Another one would be HI. Because it has no chance of intersecting and no chance of being parallel. AM is another one. JG is another one. There's a lot of skews. Okay? If we knew what the letter was behind B, then we'd have another one there. Those are all skew lines to DC. Alright, then we have parallel planes. These are planes that do not intersect. So picture in a room, these are walls that are opposite each other. They should be parallel. That's why your house stays up so well. Alright, you can also have a line and a plane that do not intersect that are parallel. Because the line would be on a plane that is parallel to the other plane. Alright, and our last example. In this diagram, this box down here, we want two pairs of parallel planes. And there's actually 3 pairs. So we'll go ahead and name all 3 pairs. Okay? So let's say I start with the top of the box. I do A, B, H, G. And that one is parallel. 2 lines mean parallel. And we have to name the bottom of the box, which is parallel to the top, in the same order. So we start with D, and then go to C, I, J. That's a pair of parallel planes. We could also do the left and the right of the box. So we could go A, D, J, G, and that would be parallel to B, C, I, H. That's another pair of parallel planes. We also have the front of the box and the back of the box. So A, B, C, D is parallel to G, H, I, J. Those are all pairs of parallel planes in this box that we have down here. Alright, And then we want a line that is parallel to plane GHIJ. GHIJ is the back of the box back here. Okay, think about what lines could be on a plane that is parallel to this. And we've already said up here, right here, what plane is parallel to GHIJ. So that means every line on that plane is parallel to that plane. So we could have AB, we could have CD, we could have BC, and we could have AD. Those are all lines that are parallel to the back of the box. Okay?